Okay, so now we are going to generalize what we did in the first two examples in our notes. And that namely shows that we're going to show that any expression of the form ax squared plus bx plus c can be transformed into that other expression, namely a times x minus h squared plus k. And then this will show that any graph of an expression like this is in fact going to be a parabola. So, and we're basically just repeating the steps we did in the last example. If we start with ax squared plus bx plus c, as long as a is not 0, we can factor out an a. We get x squared plus b over ax plus c over a. By the way, I should tell you that you won't be responsible for duplicating this on a test or anything, but just want to show you where this goes. Then we complete the square again. We take one half of b over a is b over 2a, then we square that. So we add and subtract that from both, and then once again we take these first three terms, and that becomes this expression here. And we distribute the a, we get, when we square this, we get b squared over 4a squared. And then we have we'll have a c over a here. We can get a common denominator by multiplying and dividing this by 4a, and so we get a common denominator, and we can add these terms. And we add these terms, and then we multiply by a, and the a is going to knock out one of the a's here. So that's why we get b squared minus b squared plus 4ac over 4a. And again over here we get x plus b over 2a. And then if you just look at the bigger picture, remember a, b, and c are just constants, right? So we have a times x plus a constant squared plus another constant. Well, x plus a constant really going to be it's the same as x minus a constant. We can just say this is x minus h, where h is negative b over a, and then k is going to be this expression minus b squared plus 4ac over 4a. Okay. And so what we've actually done is we've actually not only have we shown that this is the graph of a parabola, but we can explicitly find what the vertex is. The x-coordinate of the vertex will be minus b over 2a, and the y-coordinate will be this expression, minus b squared plus 4ac over 4a. Now this you don't really have to memorize this. You might memorize this, but not this, because we can see that we can compute whatever number this is, and then plug it back in here into this equation for y and just compute that directly. We can also clearly see that what the y-intercept will be. We just plug in x equals 0 and get c. And then to find what the x-intercept will be, well, we can go ahead and maybe we'll work with this equation right here. We can plug in y equals 0, and then we'll get a times x minus h quantity squared plus k. Subtract k from both sides. And divide by a. And take the square root of both sides. And then just add h to both sides. So x would be h plus or minus the square root of k over a. Now this formula, I don't want you to memorize this. I just want you to see where this is going from. But we're essentially, and by the way, I think I forgot the minus sign here. Oops. Okay, that's kind of important. Now you'll see that, well, can we take the square root of a negative number? No, but we don't know what the sign of k is. Okay, if k over a is negative, then minus k over a is positive. Okay, and then we'll get a square root. Now, if minus k over a is negative, this is not a real number, and what that means is that there are no x-intercepts. Okay, but when you do this, when you unfold everything, you can replace h with minus b over 2a, and you can replace k with this expression, and you do some simplification. We get the well-known quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. Okay. And then this is 0. And of course, as I said, this is known as the quadratic formula. And this is what we use to find the x-intercepts of an expression like this, of a function like this. All right, so now this is let's summarize everything. And now this page 4, this is what you want to memorize, and this is where we're just summarizing everything here. Okay, so a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers or real constants, and a is not 0. This is very important because if a is 0, this becomes a linear function. Now, every quadratic function is going to have two forms. It's the general form, which we see up here, and then the vertex form, which we obtain by doing that completing the square stuff we did on the last page. Okay, and because of that, the graph is always a parabola. The vertex has the x-coordinate of the vertex is always given by minus b over 2a, and to find the y-coordinate, just plug that, whatever that number is, plug it in for x into f of x and get that. This parabola will have a symmetry with respect to some vertical line. It won't be the x-axis or the y-axis usually. It's going to be a vertical line wherever that goes through the vertex, and we can see what it would look like down here. Okay, so if you know the x-coordinate of the vertex, you know the axis of symmetry. And then the y-intercept, again, we'll just plug in x equals 0, and you get c. These are the formula, the two x-intercepts, okay, what we obtained from the quadratic formula. You do want to memorize this. When you do this, make sure you extend this bar over here. A lot of students forget this minus b, and they just write this minus b over here and do that. And then the domain is all real numbers. I think we can see because we can plug any number we want in for x. And then I think you can see just from you can see that if a is positive, the parabola is opening up. If a is negative, it opens down. And in the first case, we have a local min, and in fact, the local min is actually an absolute min. It's the lowest point on the graph. And in this case, the function goes from decreasing to increasing. And in the other case, when a is negative, you have a local max, which is the absolute max, and you're going from increasing to decreasing. Okay, and the reason for that is, I think one way is you can see as x gets if x gets really large, this term is going to dominate these other terms. So if a is positive, this will be a positive term. If a is negative, this will be a negative term. Okay, so that's what so your parabola is either going to be opening up or down. And you can also see what the range is, because here the range is going to be all y values that's greater than the y-coordinate of this point. And here the range is all y values which are less than or equal to the y-coordinate at this point.